Hello guys, welcome to our YouTube channel TechBird, and today we will cover an important topic for data engineering, data scientist and SQL developer aspirants. An important topic, execution plan in SQL Server. So we will see what is execution plan, why we use it, what is the use of it, and what is execution meaning in SQL Server. So let's go through it. So I'm going to explain what the execution plan in SQL Server are and how to understand the details of an execution plan by reading the various matrices available once we hover over the components in the plan. So being a data professional, it is very essential that we must understand how to write efficient queries that turn faster results, and how to tune the slow performing queries to achieve a boost in performance. In order to understand how the database engine works behind the scene, we need to know the logical operation performed by query or processor. This can be done by investigating the execution plans generated by the query processor. An execution plan in SQL Server is a simple graphical representation of the operations that the query optimizer generates to calculate the most efficient way to return a set of results. So what is execution plan? As already mentioned, an execution plan in SQL Server Management Studio is a graphical representation of the various steps that are involved in fetching results from database tables. Once a query is executed, the query processing engine quickly generates multiple execution plans and selects the one which turn the result with the best performance. And there are two types of execution plan to be specific. First is estimated execution plan and second one is actual execution plan. So what is estimated execution plan? This type of execution plan is just a guess by the query processor about how the specific steps that are to be involved while returning the results. It is often generated before the query has been executed. Second one is actual execution plan. The actual execution plan is generated after the query has been executed. It shows the actual operations and steps involved while executing the query. This may or may not differ from estimated execution plan. So how to generate execution plan? The execution plan in SQL Server can be generated before and after the query has been executed. So estimated execution plans we will see first. So there are several ways to get estimated execution plan in SQL Server. Once the query is written completely, you can hit Ctrl plus L and it will generate the estimated execution plan. Second, you can also right click on the query. Okay, like here, right click on the query window and select display estimated execution plan from the context menu that appears like here. Just click on the query, right click and then select display estimated execution plan. Third one is alternatively you can directly click the display estimated plan icon which is available on the toolbar in SQL Server Management Studio. If you see here, you would have seen in this toolbar this icon, and this is for display estimated execution plan. And for the short key you can press Ctrl plus L. Actual execution plan in SSMS. So Control plus M. It will generate the actual execution plan after the query has been executed. Second option is right click on the query window and select display actual execution plan as shown here. Actual execution plan. Third, alternatively you can directly click the display actual execution plan icon which is available in the toolbar in SSMS. So here you can see if you hover over it, it will tell you it's include actual execution plan, and here you are seeing control plus M. So this is the short keys to display actual execution plan. Now interpreting execution plan in SQL Server Management Studio. So once you generate the execution plans as mentioned in the steps above, you will see something like the diagram below as in figure 5, like this one. So for estimated plans, it will generate as soon as you perform this step, whereas for the actual execution plan, it will be displayed only after the queries has been executed. So if you see here, you can see this is the query where select district from customer where postal code equals to 90761 ordered by customer. So here it's the execution plan and query cost 100%. Select district from customer where postal code is equals to 1 and is equals to this one at the rate 1 ordered by customer. So here you can say select cost is 0%, sort cost is 48%. Okay, and then you can see cost 52% is clustered index is scan PK dimension customer. So execution plan in SQL Server. For such simple query, the estimated execution plans are usually like the actual execution plan. For the purpose of this tutorial, we will try to understand one of the operation of actual execution plan only. So in the execution plan is depicted in the above figure 5, if you hover the cursor over the components like this one as shown here, you can view the detailed stats for each of operations and components being displayed in the execution plan. The plan is interpreted from right to left and top to bottom. Right to left and top to bottom. Right to left and top to bottom. Since our plan consists of only one single row, there is no need for top to bottom approach. So if you see hover on this and what you will see clustered index in scan. So relating to it, all the details are given here, like a physical operation is clustered index scan, predicate, object, and output list. So we can distinguish the execution plans in the following 5 steps. Clustered index scan, data flow from clustered index scan arrow, this arrow. Okay. Sort operator, data flow from sort operator arrow, and select operator. For the sake of tutorial, let's only understand in detail the various metrics that are being involved for the clustered index scan operator. The details of the other operator can also be viewed similarly. However, the detailed explanation of the metrics of the other operators is beyond the scope of this article. So clustered index scan. So the first component when we traverse from right to left is clustered index scan component. If you see here, so what you will see if you traverse from right to left, the first element is clustered index scan. Then it is arrow, then sorting 48% and then select. So the execution plan step is from right to left and top to bottom. But as in our case there is only one single line, so how we cannot go top to bottom because there is only one row. So right to left we can move in it. So here you can see this index scan is performed on the primary key of the table. Okay, that is PK dimension customer. If you see here, PK dimension customer, this one. So object is this one. Okay, let's understand each of the metrics that are being displayed while we hover over the cluster index scan operator. You can refer to figure C1 for understanding more. So first one is physical operation, this one, and it is showing physical operation is clustered index scan. So these are the operators that implement the operation as directed by the logical operators. So all the physical operators are usually uh, object which perform an operation. Some example are clustered index scan and index seek scan. Second one is logical operation. Here you can say, so it's these operators describe the actual algebraic operation that is used to process the query. For example, write anti semijon has joined etc. Actual execution plan. So actual execution plan is row. So this is the actual execution mode that is used by the processing engine to execute the query, example row and batch. Estimated execution plan, similar to actual execution mode but shows the estimated value. Storage. This tells us how the query optimizer will store the results that are being extracted by the query. So storage is row store. Number of row read. This returns the total number of records that are being read by the operator from the table index. So here you can see it's reading 403 rows. Now actual number of rows. This tells us the total number of records that have been returned based on the condition in the where clause. So here you can see actual number of rows is 3. Actual number of batches. If the execution mode for the query is batch, then it will list the number of batches being executed to fetch the results. Estimated IO cost. This tells us the cost of input-output operation of the result set. Estimated operator cost. This is not an actual cost but relative information with respect to other operators in the execution plan. Estimated CPU cost. That CPU will incur in order to process the operation. The estimated subtree cost. The cost of execution tree that is being currently read from right to left and top to bottom. So this is the subtree cost, cost of execution tree. Number of execution. It tells us about the number of execution that optimizer can handle in a single batch. Estimated number of execution. This is also similar to number of execution, just the estimated value, estimated, not the actual. Estimated number of rows. The number of rows that optimizer thinks will be returned by the operator. Estimated number of rows to be read. Number of rows that optimizer think will be read by the operator. Estimated row size. The storage size each row in the operator. An actual rebinds. This tells us about how many times the evaluation of the object must be done in order to process the operators. Actual rewinds. This property tells us if there are any changes in the correlated values for the object that is being processed, ordered. This property determines if the dataset on which the operation is to be performed in a sorted state or not. Node ID. It is the automatic assignment of a number in the order in which the operator is uh, called in the execution plan, reading from right to left and top to bottom. Additionally, if you see below, there are these three properties that tell us more about the query and the object on which the plan is generated. Predicate. This is the value retrieved from where clause in the SQL statement. Object, the table on which operation is being performed. Output, the selected column are being displayed in the result set. You can also right click any operator or arrow in the plan and select properties or to learn more detailed explanation of the matrix displayed in the tooltip. So saving an execution plan in SQL Server Management Studio, sometimes it is essential that after interpreting the plan generated by the query, you might want to save it for future reference. SSMS provides an option to save the plan in the file system with an extension of SQL.xml plan. So in order to save an execution plan, please follow the steps below. Right click on the plain window and select Save Execution Plan. Third, select a location and provide a name for the execution plan and click Save. You can open the plan as and when required. Conclusion. So we have learned what execution plans in SQL Server are and how to generate one. We also walk through various metrics that are being considered in the operators used in the plan. Finally, we have seen how to save an execution plan in SQL Server Management Studio to the file system and use it for future references. So I hope you like the video, and you can put your comments in the this tutorial's comment box for your suggestion what type of video we can make. So I hope we will meet you soon with new videos. Till then, goodbye.